Hello again, cadets. Today we're going to talk about how to determine the number of distinct ways, this time license plates, with the counting principle. All right, so talking about license plates, we got license plates is 1, 2, 3, 4, 5, 6 digits. And for those 6 digits, we can have any of the numbers 0 to 9. Well, how many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible digits in each space in the license plate. So, in the first space, I got 10 choices. Okay? And I can do it again. I can have, because this time we're talking about with repetition. That's a cool word, repetition. I can repeat. So I could have 0, 0, 0, 0, 0, 0, or 9, 9, 9, 9, 9. Okay, what if I only had license plates with just 2? Well, I could put a 0 and a 0, and then stay with the 0. I can go, well, let's say I'll keep the 0 here. So I go 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0. That's 10. Then I'd switch this to 1, and I'd go 10 again, 10 again, 10 again. So I have 0 through 9 here, and I can put 10 different choices here. And 10 different, if I got 6 slots to go, and I have 10 choices for each one, the counting principle states that the number of license plates that I can print with 0 through 9, 6 spaces, is 10 times 10 times 10 times 10 times 10 times 10. Now, on your calculator, I encourage you to find 10. You put in 10, then you find this x to the, and there's a to the little square, x to the, and then you can put in 6. So 10 times 10, you remember your exponents, 10 to the 6th power. This is with repetition. If I can say 0, 0, or I can say 0, 1, 0, 7, 8, 9, whatever, okay? I can repeat repetition. I can repeat. I'm repeating myself right now. A lot of repetition here. Okay, here we go. What about without repetition? What does the counting principle tell us about this? This is kind of interesting. Let's see. Once again, we'll just start with 2. We'll think about that. Well, I got 10 possibilities in the first one, but I can't repeat, right? So I've taken away one of my possibilities. Say I put a 0 in here. I have to take away here. Now, for the second space, I only have 9 possibilities, and so on, right? On down, and I've got, let's see, is that 6? Yeah, 6 slots again. We're talking about these license plates with 6 digits, and so I've taken away 2 of them. I can't repeat them, so now I'm down to 8. So okay, so it's going to be 10 times 9 times 8 times 7 times 6, 7, 6, 5 times 5. So there's a neat, so you can go ahead and do that in your calculator. There's a neat way of saying this would be, we're going to talk about factorial in just a second. We'll skip this. So this is if I cannot repeat. Without repetition, whatever that number is, you have to put it in your calculator. 10 times 9 times 8 times 7 times 6 times 5. So with repetition and without repetition, you got 2 different amounts. You can compare this number with this is easy over here, 1 million, right? 10 to the 6th power is 1 million. Well, this will be quite a bit less than 1 million. Okay. And at the risk of making this too long of an introductory, here we go. Mr. Chad's talking too much again, but here we go. Cadet leadership positions. So here's another time for the counting principle. What if I had just 3 cadets, and I got company commander? These are American positions. I don't know how y'all call them with your cadets. Company commander, executive officer, first sergeant, all right? If I had just 3 cadets, and they're all equally qualified, right? So I have 3 cadets. For my first choice for company commander, I have 3, right? I have 3 different cadets I can put in there. Adib, Ibrahim, Abdul Rahman, right? Then, since I've assigned somebody company commander, then I only have executive officer. I've only got 2 choices. And here, this is called, the way we call this, 3 times 2 times 1, that'd be 3 factorial equals 3 times 2 times 1. Okay, what if I had 4 cadets? All right, well, for the first slot there, I add in Ali. Okay, then I'd have 4 choices for company commander. And I've taken away 1 choice, right? I can't have Ali twice. So I put in another choice here, okay, Ahmed. Okay, so, and then I've taken away 2 of my cadets. I've only got 2 left to choose from. So then I've got 4 factorial divided by 1 factorial. So I got 4 times 3 times 2 times 1 divided by 1. Okay, let's try it again. We got 5 cadets now. It's going to get a little messy, but you're getting the idea. So I have 5 cadets. I have 5 cadets for the first position. Company commander. Then I have only 4 left. You guys are getting this pattern now? So I'm going to have 5 factorial divided by 2 factorial. Because then I'd have 5 times 4 times 3 times 2 times 1 over 2 times 1. And leave them with 5 times 4 times 3. So, here we go. If I have 60 cadets, how many possible combinations can I have? Permutations is actually the word, but we're not going to worry about those fancy words right now. How many different leadership structures, and if I'd only had 3 leaders I'm picking, can I have with 60 cadets? Well, I got 60 choices for company commander. I have 59 then left for executive officer, and I have 58 left for first sergeant. So you have 60 times 59 times 58. You guys can throw that in your calculator. Different ways to choose your leaders if they're all equally qualified. Okay, this is way too long. And so 6 factorial, one last time, n factorial, n exclamation point. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. I think I got that one in my head now. 720. Long video. Thanks for paying attention.